my name is Casper Andersen, and I've been working on deploying Optimate for Materials Cloud, where we serve databases based on Aida. And so Aida is an open source framework written in Python, very general here, which helps researchers create and submit workflows and calculations and so on, and stores it in a PostgreSQL database with a local file repository as well. Within Aida, you can use to search for your data. You use a Python interface, which converts these graph-like queries to SQL queries. Now, Materials Cloud is an open science web platform where you can store databases. Some may be Aida databases as well. And these Aida databases you can then explore and look through. So they are, in a sense, immutable databases stored. They get a DOI, which is connected to that specific version of the data. You can change some metadata around it, but that's it. Yeah. And at the moment, we serve these through the Aida REST API, as well as a front-end Explorer on Materials Cloud. And a few are now served with the Optimate API as well, specifically using the Aida Optimate repository. Just to mention it, we also have an index metadatabase, and this is apparently, we are the only ones at the moment, which is served at this URL here, or generic with these two endpoints. And this is to create a central space wherewith we can basically proxy through to, not proxy through, but direct other people, or clients to the various Aida databases and the Optimate API endpoints for those databases. And this is very simply deployed using the Optimate Python tools. Just a very small configuration and then run it. It's very easy. You'll hear more about that tomorrow, hopefully. So about our Aida Optimate implementation, it is it's based on the Optimate Python tools again. So it's supporting the latest version, which it also supports, which the Optimate Python tools also supports, which is version 0.10.1, or rather it's very close to the release candidate. So this means that all required properties and requirements, hard requirements that should be there for the latest ones are met, and a bunch of optional ones as well. There are a few edge cases which are missing, but again, we'll talk about that tomorrow. We have a specific transformer for the Python specific Aida search API, and then it serves the structured data nodes, which are what in Aida represents crystal structures. Yeah, and to optimize the speed, we actually update the database with the calculated Optimate property fields, so that you can search that directly on them the first time you make a search. The database is updated. And it's not just for use on Materials Cloud. You can use this on your local Aida database if you have one of those as well, just like the Aida REST API. All right. So for Aida and Optimate, there is a database importer system within Aida as well. And for this, I would like to develop a native Optimate database importer as well. Andreas knows that these exist. He developed one for COD. And I would like to support the file data structures that we have in Aida as well, specifically for CIF files. And then because Aida is this workflow calculation framework, then it would be nice to also have an endpoint for these to be served with Optimate. And then eventually you could reconstruct the whole knowledge graph that we have. Finally, I would like to plug the client that I've developed recently in Jupyter. You can find it at this URL. And I was hoping as well that just as we were talking about Optimate Python tools, we could at some point maybe just go through the various clients that have been developed. Because I saw one from Evgeny, which is very nice, using cores. And there's Marcus has one as well, and Matthew has one. And this is then developed in Jupyter. You can find it here. And at the moment, it uses the Optimate providers repository and the materials consortia providers endpoint to retrieve all providers from there. And at the moment, there are only 2 at the latest version. So this is Materials Cloud and Matthew's OMDB. Be nice to get more. And there's some basic inputs here where you can search on the number of elements and sites and so on. Thank you.